guys, welcome back to my YouTube channel. So today we are going to solve day 19 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 769, max chunks to make sorted. Okay, so in this problem you are given an integer array of length n. Okay, so see this example number 1, array length is 5. Okay, that represents a permutation of integers in the range 0 to n minus 1. Okay, so see in this array we have elements from 0 to n minus 1, that simply means 0 to 4, right? We split array into some number of chunks, okay, the partitions, and individually sort each chunk. Okay, this is what we need to do. After concatenating them, the result should equal to the sorted array. Okay, we have to return the largest number of chunks we can make to sort the array. Okay, so see this example number 1. So first let's say I take this complete chunk. Okay, and if I sort this, I will get the elements like this: 0 1 2 3 4. Okay, so this is sorted array. Okay, so now if I try to split this array in two chunks. Okay, let's say I try to split it here. Okay, so I will get elements like 3 4, and here 0 1 2. Okay, after sorting, so this is not a complete sorted array, right? If I join them. Okay, so we can't split it in more than two, right? Two or more than two chunks, right? So splitting into two or more chunks will not return the required result. For example, splitting it into 4 3 2 1 0 will result in 3 4 0 1 2. Okay, which is not sorted. Okay, so max is 1 only, so that is why we are going to write 1 here. Okay, now see this example number 2. So here I can split this array in four chunks like this. Okay, so I will get here 0 1, take this individually, I will get 2, take this individually. Okay, 3, take this individually. We have to return the max now. So here 1 2 3 4 chunks, right? We can split into two chunks. Okay, 1 0 2 3 4, but splitting into 1 0 2 3 4 is the highest number of chunks possible, right? So that is why output is 4. Okay, and constant size, see here, just 10. Okay, very small constant size. Okay, so now how we are going to solve this problem? Okay, so let's take this example. Okay, I am going to show you two approaches today. Okay, two approaches today, and both approaches are very simple. Okay, so let's first solve using approach number 1, which is maximum element. Okay, so let's take this example. So we have this array 1 0 2 3 4. Okay, 1 0 2 3 4. Okay, and let me just give the indexing here. Okay, so this is 0, this is 1 index, this is 2 index, and this is 3 index, and this is 4 index. Okay, so these are nothing but indexes. Okay, these are nothing but indexes. All right, so here we have to just here what I'm going to iterate over this array. Okay, so first I am at this position. Okay, I am at this position. So what is the max element at this position until here? So just 1. Okay, 1 is the max element. Okay, and this max element is not matching with this index, right? So I'm not going to do anything. Okay, now let's say I move to this position. Okay, so if I move to this position, so here what is the max element in this particular range? Okay, max element until here. So max element, if you see here, it is nothing but 1. Okay, at this position. Okay, max element is 1. Okay, so here 1 is max element, and you see at this position we have 1 only. Okay, this index is 1 only. So if max element, okay, and the index both are matching, then just increment the count of chunk to 1. Okay, so chunk count will become 1 now. All right, so yeah, this is one chunk, right? So 1 0, so you can sort it like this, 0 and 1. Okay, so here I'm saying whenever the max element is matching with that particular index, just increment the count of chunk. Okay, so now let's say I move further. Okay, so I move to this position. All right, so until here tell me the max element. So what is the max element that we have? Okay, so the max element that we have is 2. Okay, and this index is 2, so increment the count of chunk. So chunk count will become 2. Okay, then move further, move to this index. Okay, until here the max element is 3, and this index is 3. Okay, so increment the chunk count to 3. Okay, then go here, max element until here is 4, and this index is 4, so increment the chunk count to 4. Okay, so this 4 is output, right? So 0 and 1, this is one chunk, 2 is one chunk, 3 is one chunk, and 4 is one chunk. Okay, now let's take this example 4 3 2 1 0. 4 3 2 1 0. Okay, and let me just give the index in here: 0 1 2 3 4. Okay, so now we are going to do the same thing. Okay, again, so here at this position. Okay, so first of all find the max element. So max element, this element, and the max element of initially, let's say 0. So max element until here is 4. okay, and this is not matching with this. Okay, now let's move further. So until here again max element is 4, okay, and it is not matching with this. Move here until here max element is still 4, and this is not matching with the text. Until here max element is 4, and this is not matching this one. Okay, now I move here until here the max element is 4, and this 4 is matching with this I value. Okay, so if it matching, then increment the chunk count to 1. Okay, right? So here see, this is the only best case, right? So until here the max element is 4, and until here the index is 4. Okay, both are matching, so that simply means that we can completely sort this. Okay, we have all the elements from 0 to 4 until here. Okay, that's what we need to do, right? Simple. So chunk count is just 1. Okay, so this is nothing but my approach 1. So let's write the code for approach 1. So it's very simple, right? So first of all, let's calculate the length of array. Int n is equal to array dot length. All right, and take the initial count of chunks to 0, and max element take it to 0. All right, and then we are just going to iterate over the array for int I is equal to 0, I is less than n, I plus plus. All right, and here after that we have to update the max element. Okay, max element is equal to math dot max of max element, and here array of I. Okay, that particular element. Okay, array of I. All right, and here I'm just going to check if max element is equal to I. Okay, in that case simply that simply means that all values in the range 0 to I belong to the prefix array of 0 to I. Okay, a new chunk can be formed. Okay, so here this 4 is matching with this max element. So until here we have all the elements, so this is just forming one chunk, right? So this is the same thing, this is forming one chunk. Okay, until here max element is 1, and this, okay, so it is forming one chunk, right? So this is what we need to do. So here just increment the count of chunks, plus plus, and in the end just return chunks. Okay, that's it. So this is nothing but my approach 1, return chunks. Okay, now to just run it and see if there are code issues. We'll try to fix that. Submit it. Okay, all the test cases has been accepted. Let's submit it. So see, our solution is accepted, right? And the time complexity is going to be O(n). Okay, since we are iterating over alignments 111. Okay, so now let's move to the approach 2. Okay, so take this example only 10234. Okay, approach 2, I'm going to solve this problem using approach 2. So this is my array 102. Okay, then 3 and then 4 we have. Okay, so uh here just calculate the prefix sum. Okay, so until here prefix sum is 1, until here it is 1, until here 1 plus 0 plus 2 3, 1 plus 0 plus 2 plus 3, until here it becomes 6, and here 1 0 2 3 plus 4, here it will become 10. Okay, so this is nothing but my prefix sum of my actual array. Okay, now let's see if I sort this array. Okay, so if I sort this array, then this array is going to look like something like this. Okay, 0 1 2 3 4. Okay, so prefix sum of sorted array, this is what I'm going to write here. So it is going to be here 0 1 3 6 0 1 plus 2 plus 3 6, and plus 4 is 10. Okay, so this is the prefix sum of the actual array. Okay, this is the prefix sum of the sorted array. Okay, so here see, this value is not matching with this value. Okay, so nothing. So here this value is matching with this value, so increment the count to 1. Okay, so increment the count to 1 here. This value is matching with this one, so increment the count. This value is matching with this one, so increment the count. This value is matching with this value, so increment the count. So see here, other than this all other values are matching. Okay, all other values are matching, right? So that is going to be my output 4. Okay, chunks is 4. Okay, so here what we are doing, we are going to update the prefix sum of the actual array, we are going to update the prefix sum of the sorted array, and if the two sums are equal, then two prefixes contain the same elements, right? A chunk can be formed. Okay, that's a simple meaning, huh? So here see, here we are getting 1 1. Okay, 1 1, and here we are getting 0 1. So see, we the elements are unique, right? Elements are unique, and elements are unique. Okay, this is what we know. And until here, sum is one, and until here in the sorted array, sum is one. So that simply means that we are using the same number of elements until in the complete set. Okay, so that's the case, right? Here we are using 1 0, and here we are using 0 1, because we know the elements are unique. Okay, and that is the reason we are going to count like this. Okay, that is why this logic works. Okay, because the elements are unique, and if the sum remains same, okay, if the two sums are equal, the two prefixes contain the same elements, because we know that elements are unique, right? Okay, that simply means a chunk can be found. Okay, that's the simple reason. Okay, so this is what we need to do. This is nothing but my approach 2. So let's write the code for approach 2 now. So okay, so this is okay. So here, instead of max element, now take the prefix sum. Prefix sum is equal to 0. Okay, and here sorted prefix sum, and take this to 0 as well. Okay, and now we are just going to iterate over the array. Okay, and here we are just going to update my prefix sum. So prefix sum, just let's just copy this. Okay, prefix sum is equal to prefix sum plus the element of this particular array. Okay, and this is what we are doing for the updating the prefix sum of the array. Then we have to update the prefix sum of the sorted array as well. So just copy this. Okay, and paste it here. So sorted prefix sum is equal to sorted prefix sum plus the I. Okay, i I sorted. Okay, because here these are nothing but the indexes only. Now if I take this 0 1 2 3 4, so these are indexes only. Okay, if I sort the array or indexes, so both are going to same only, 0 1 2 3 4. Okay, so here I'm just going to do I. Okay, and here we are iterating. Okay, and here I will just check if my prefix sum, okay, if it is equal to sorted prefix sum, then in that case only just increment the count of chunks. Okay, that's it. All right, and then we have to done check success. Now let's run it and see if there are code issues. We'll try to fix that. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand both the approaches. Okay, for this approach also the time complexity is going to be often. Okay, so I hope that you guys are clear with both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in next video. Thank you. Bye bye.